today?
Okay, I am planning these classes for at the very least a month. So for the first 2 weeks, we will be learning C, file pointers, and basics, basically, right? What you said, advanced such as pointers, file manipulation, structures, custom data structures, that will be covered in the first 2 weeks. The next 2 weeks, I am planning to cover data structures such as linked list, stack, queues, trees,
Yeah,
and those things.
Okay, I'm just
And
sharing the agenda
to
for today. So
to ask you a question, your question is for Hacker Earth or for Hacker?
Hacker Earth, Hacker Rank.
हाँ बिल्कुल. And my question is, what is the difference between C for Hacker Earth or C for Hacker Rank?
Yeah.
Yeah, my question is, what is the difference?
No, no, no. I'm telling you, Hacker Earth, Hacker Rank, you know very well than me. It's a
Yes.
website. You are taking the quiz online,
Yes.
online coding round. So it's a very big, complicated, and because you are taking the online intensive also. So it's a very best for us. So that's why I think you are telling that questions from Hacker and Hacker Rank Hacker Earth
No, no, no. This is nothing
questions.
like that. You have to solve your Hacker Earth programs by yourself.
Okay, thank you, sir.
I'm just teaching C programming. And this is the agenda for today. So we will be starting with why you should learn programming, basically.
Okay.
So we are starting from why programming, what is the point of programming, hacking, and how to write your programs and things like that. What you are asking is that is competitive programming, which we do not have any need for in our InfoSec. Competitive programming is required mostly or almost exclusively in development jobs. And since we are all in InfoSec, so we will not be covering anything of the development jobs, right?
Right, sir.
yeah.
Okay, so I think we have some
Before
time.
when you start, let's have a look on questions that we ask you guys when you are doing the sign up. Okay, so we had a small form that we are like, hey, if you got any questions, you can go and ask. So we got few questions from this place that is here. Now, there's a few questions that is repeating itself, so we're not going to answering all of them individually. So just pile it up and answer it once. Okay, so let's start. So what I did, I just make the questions with their names. So that will be easy for everyone to go through their names and look for the questions.
I don't think there wasn't a need for names, but I mean, we can do anything. The names are in front of everybody.
If you want, I can hide it.
Delete it.
Yeah, let's hide it as well. We just have the questions.
Great. So what we have is the first question is what will be the timing? Okay, there's no point.
So this is, we can just make it as answered. Doesn't make any sense. What will the timing? We already answered it. I
Okay.
don't know what to do with this. Do with this.
Is there
Any
any
particular
particular
function?
No.
So,
Okay, so there is no particular function that we guys are exploiting. We are learning how to program in C language. So single word, I don't know C language, help me, sir. Okay, that's what we are doing.
we are just trying to you answer your question. So no, nothing. How do you say to learn basic? Manshu, this one.
Ek second. How do you see as a base to learn other languages effectively? That will be answered over 2 weeks in this whole session. So in 2 weeks we'll be having six sessions. Each session will be यार किसका माइक है यार माइक बंद करो
मैंने सबका माइक बंद कर रखा है
बहुत बढ़िया okay so in those 2 weeks in those 6 sessions we will be learning how to use C as a base to learn other languages effectively. Although the point is each language is pretty much the same and different at the same time, so you can and you cannot use C as a base to learn other languages effectively. But yeah, okay. Timing of the session 6. End goal of all the sessions. So the end goal of all the sessions is not to teach C or C++, but the actual end goal is because I hosted a few sessions last time. So my previous sessions were on uh,
It's available with us. So I will be sharing up the link right away.
yeah.
So
So
if you
we
go to
had
our website,
I I did a previous series, and if you okay, so there was okay, I did two series. One was exploit development, and one
yeah.
was designing rootkits.
So what I did for your convenience, just click on this link, the series one, and it will take you to the page where you have all those things. So brief introduction to your speaker who's talking to you right now, the events with the date and the time, and there will be updates for each and every sessions, what we are teaching about. You can click on the YouTube after session, it will be available on that place. So yeah, you can watch later on if you miss something, or you just go through again.
Okay, but हम दूसरे क्वेश्चन को जवाब दे रहे थे.
Acha.
So the end goal of the session is to cover the distance. So I did two sessions before this, two series. One was on expert development, another was on rootkits, and anything related to operating system related things such as reverse engineering, malware analysis, or malware development, or rootkits, or anything, right? So those things require you know native API, and native APIs are in most cases either accessible through C or C++, or other languages have an interface which is kind of typeset in C or C++. So therefore it is very essential for you to understand C, C++, so that you can understand reverse engineering, exploit development, malware analysis, because without those things, without the understanding of C or C++, you would not be really able to do much if you don't know how the underlying system API works or how the underlying things are programmed. So this is the end goal of the sessions, to help you uh, better in terms of whether you are learning exploit development or reverse engineering or malware analysis, right? Now get some knowledge. Take care. I do hope. Yes, we will record sessions. Animesh already told everything. All the sessions will be on YouTube. How many hours per session? 1 to 1.5 hours per session. Okay, is C programming also used for hacking? No, C programming is not used for hacking. So if you are here for that, I would say you are in the wrong place. I'm just an enthusiast. Can I attend? Probably you can attend. Okay. Will you explain how to code it for companies coding test? No, we are not someone who prepares you for coding tests. That is what you have to do by yourself. We will teach how C programming works. So how to code for companies, that is you have to do, right? So hope to see you in webinar where the C language is used in hacking. C language is not used in hacking. So if you are here for C, नहीं उसके नीचे 145.
145.
Okay, so if you are here to use C language in hacking, I would say these sessions are not for you. And what is the syllabus that we will be learning? Uh, the syllabus will be shared for each session prior to the session details. For example, we shared the syllabus of session one, and since the next session is going to be on day after tomorrow, today evening or tomorrow, when we will share the link of registration or something, we will be sharing the syllabus of the next session. Now coming to question, learn C program in terms of, okay, will there be recorded version? Yes, that there will be a recorded version of training. So I think we have covered all the.
There is a other question from YouTube.
Okay.
Just came up. Will you teach socket programming using C?
Yes, we will. We might. I have not planned specifically for socket programming or system programming, but we do have space for that thing. So uh, if we are going through the route of system programming, so we will be doing some network programming tasks as well.
Okay, so I'm gonna do one thing. I'm gonna mute everyone, and I'm gonna take permission from to unmute yourself.
Okay, so I had another question in the chat, that is, what are we actually developing with C language in this series? Is it learning making keylogger reverse shell server? We are not developing anything in this series, to be honest, because we already had a series where we developed rootkits for Linux. That was a three-part series in C. We had a series of 10 parts writing malwares through C++. So where that series was not by me, but again, the point is that has been covered. So you learned how to code reverse shell, you learned how to write keylogger, you learned how to write server. So I don't really think there is any need to really repeat those things again.
For null,
So first, yeah,
this is a playlist, right? The design rootkit. So this is from Himanshu. He had three talks for this particular query that you are having right now. And for malwares, we have a dedicated series for that. And if you go to homepage, there will be one speaker who have his talks with us. That will be on event page, naming as it's on archive right now, one with malware. And here we'll find all those things that you're looking for right now. So we have the code that you can use and start working on. And we have all those informations that you might need to start over.
okay. And another thing is you will be we will be sharing as always code files, but from this time onwards the code files will be shared once you fill the form of feedback, right? So we always take feedback after the session. Some people do, some people do not fill the form. So to get more feedback, the thing is, if you require the code files, just fill the feedback form. Tell us how you like the session. Was there something to improve upon or anything else, whatever you like in the feedback. And once you fill the feedback form, you will get the files for the session, right? So that you can follow along.
Dexter raised your, yes, Dexter. I'm gonna unmute yourself, so you can ask. Dexter. Yes, you can ask your question now.
I don't think he wants to ask a question. Okay, so if you have any question, you can simply raise your hand or even type in the chat. I'll be checking the chat. I will keep open the chat box. So every time I'll be looking at it. So there is no problem if you are unable to talk. So let's start with C programming.
Okay,
So
just one quick thing. For YouTube viewers, we are taking questions from YouTube as well. So you can just type in there and I will be passing it to our speaker.
okay, so the
Yeah.
question is, what do I need to get started? Anything. I mean, I will be using Linux and GCC as my C compiler. If you are on Linux, you can use GCC, or if you are on Windows, I would suggest Microsoft Visual C compiler. But if you do not want that, you can use any other compiler. For example, something that comes with code blocks. I don't think any compiler comes with code blocks, but again, the point is you can use any system which has a C compiler on it. Okay, so let's start. Let me share my screen. अनिमेश
Yeah, wait, मैं permission
नहीं
दे.
एक सेकंड तो पहले वो शो कर दे पेज
Okay.
एजेंडा आज का शो कर दे एक बार
एक second कर रहा हूँ.
Okay, so this is the agenda for today, what we are going to cover. First thing is fundamentals of programming. So we are going to start with why you should learn programming in the first place, right? So what is the point of having these sessions, and these month-long sessions or something else on C programming, where in place of these sessions, we can have something else, for example, pen testing, web application hacking, or something else, right? So first we are going to cover why we are learning programming, what is the relevance of programming in hacking, how to design your program, and once we do that thing, we are going to talk about program design techniques. For example, how to design your programs. Is the bottom approach better or the top down approach better when you are designing programs? What are those approaches in case you do not know? What is scalability and why you should care about it? How to structure your programs or how to design your programs so your design is scalable. Now, once we have those basics covered, which are more or less some abstract terms, we are going to start with basics of C programming. So just a second, I'm starting my stuff. Okay, now I'm sharing my screen.
Nope, you cannot. Wait, I can share your screen.
Okay, so I think you can see the screen, right?
Yes.
So during the session, please to explain how. Okay, we will explain those things. In case of compiler on Linux, it is GCC. Yes, by default, it is GCC. Okay, so let's start with the fundamentals of programming. So why should you should learn programming? Now, if we are talking about being in InfoSec, right? Let's suppose you are not in system development or system programming related fields. Let's suppose you are only in web pen testing or something, but you do not know programming. You can only rely on tools as long as those tools work properly. Once those tools do not work as expected, or there are some edge case scenarios where the tools fail, then it becomes imperative either to write your own programs or to modify those existing tools given or taken that the source code is present. For example, let's suppose you are trying to exfiltrate some SQL injection data from SQL injection vulnerability, but SQL map is crashing for some reason. If you don't know programming, if you do not actually understand what goes in SQL exploitation and stuff like that, you will not be able to solve that problem. So this is the point that differentiates normal hackers or normal professionals from very good professionals in our industry, right? So same goes with any other thing. For example, let's suppose you are doing reverse engineering or malware analysis. So until and unless you know how to program your debugger, or because some debuggers come with scripting capabilities, right? So until and unless you know how to script your environment, how to speed up your analysis, you are going to get limited. But once you are able to script things, once you are able to write your own scripts to analyze binaries, to analyze programs, to analyze malwares, right? So what you can do is you can just automate every single thing. You might have heard about sandboxes, right? So what a sandbox does is it is basically an environment which executes the binary and records everything it does and produces a report. So that thing can be done by hand, and before sandboxes that was done by hand. But sandbox is one of the applications where you can just write a code, or you can write something that does all the analysis work and produces a report, basically allowing you to analyze something between 1 to 100 or 1,000 malwares per day, where you were stuck with had you not had the sandbox, right? You would have been stuck with analyzing a single malware for multiple days. So this is why you should learn programming. Now, another thing what programming helps in is programming provides you a proper structure to thinking or to a thought process. So when you learn programming, you learn to think in a proper structured manner. And once you know the structured manner, because at the end of the day, if you are going to automate anything, if you are going to automate your burp suite or anything, right? It can be debugger, it can be decompilation, it can be uh, data exfiltration, it can be pivoting and um, anything, right? It can be basically anything. So the thing is, it has to be done by the computer, and since it has to be done by the computer, it must be told to the computer in a specific way. And to tell computer to do something, that is basically programming. So the more you know about programming, the more experience you have of programming, the better you are going to be in your domain or in your field, right? So I think you all get the point why we do need the programming part, right? Okay, so moving ahead now, how to design your programs. So the next question is how to design a program. So when designing programs, we have multiple approaches, and which we call basically multiple paradigms. So multiple paradigms have we have paradigms in terms of programming languages. For example, procedural language, functional language, object oriented programming languages, and things like that. However, in terms of program design, you can say you can either start with a bottom up approach or you can use a top down approach. So in a bottom up approach is when you take the problem and you come to the smallest point, right? You come the most fundamental thing and you start building things. For example, let's suppose you are trying to build a computer. So the most fundamental thing would be a circuit, right? So you start with circuits. You build circuits, you do stuff, and then finally you create memory, and then you create storage, then you connect those things, and then you create a computer. So that is the bottom up approach, or else, right? So another thing is the top down approach. So top down approach is where you start from the very top and you break it down in multiple things. For example, you start with taking the same computer approach. We see that there is memory, there's the memories, then hard disk, or the runtime, not the runtime memory, the memory which is used as RAM, right? So the secondary memory or the primary memory, right? And the primary memory, after the primary memory, we have different types of memory. So, for example, we have caches. Then after the caches, we have registers, right? And registers are again built of different logic circuits. So, in the top-down approach, you start from the very top, and then you keep dividing the problem into different sub problems, and at the end, you end with a problem which can be solved, right? So you, at the end of the day, once you have identified the very basic problem, you create a function to solve that problem, and then you just combine those approaches. So bottom up approach is usually, in most cases, used by object oriented programming, though you can use bottom up or top down approach with almost any other programming style. Now, bottom approach is usually used by, I would say, object oriented programming, whereas C usually uses top down approach. And as I said, you can in most cases use any of the approach until unless there are some serious difficulties, right? Now, the choice depends upon how hard it would be. Some problems are easy to solve in top down approach, some problems are easy to solve using bottom up approach, and therefore it is essential for you to understand what the bottom up approach is and what the top down approach is and where to use which one. So once you have figured out which approach to take, we are going to think about something else, which is scalability. So what is scalability? Now, scalability is something which lets you do things, or scalability is the process which lets you scale. So to scale is to grow. For example, let's suppose you were running a fuzzer, or you were fuzzing a file on your system. So most people have one laptop versus computer. You can fuzz on a single computer, but let's suppose you want to you want to run fuzzing on a large scale. So what you can do is you can buy additional storage, you can buy cloud storage, and then you are running fuzzing on cloud machines. For example, you have 10 machines on the cloud, or you have 10 virtual machines on your cloud, and you are then fuzzing on those 10 machines, which will ultimately increase the output, because now you are at the very least doing more work than you were before. So that is scalability. And why we should care about it is because you should be designing your programs in a way which, if scaled, would work properly. Because in case you do not care about scalability and you write a program, but then it for some reason you need to scale it, right? Let's suppose you are in a company, or let's suppose your project needs to work on multiple machines. So if you have not designed it in a way which is scalable, then you might need to rewrite it again, because you need scalable, right? If you take the scalability properly, if you take the design, if you make the design scalable from the very beginning, then there would be no problem and you can scale properly without any problems, right? So those were the fundamentals of programming. Can you help me understand what is the horizontal scaling and vertical scaling? uh, Unfortunately, I do not know more much about the difference between horizontal scaling and vertical scaling. What I'm talking about is um, just in okay. So uh, I don't know much about. I don't know difference between horizontal scaling versus vertical scaling. But what I am talking about is at a certain point you have to, you know, move things about. For example, you were using a program which was then converted or which was then used as an API. So you need to think about that way, right? I think I would be able to tell them. Let's see what is the difference at horizontal scaling versus horizontal scaling and vertical scaling. Okay, so the most basic answer is horizontal scaling means you add more machines, and vertical scaling means you add more power. So horizontal scaling would be okay. So horizontal scaling would be instead of using a single machine for fuzzing, you are using two, three, or four machines. Whereas vertical scaling is you increase the capacity of your existing machine. For example, it has more RAM or it has a better CPU. Instead of i5, you replace the CPU with i7 or i9. So that is what I can find out, right? Could you please also talk about optimization of code in terms of code lines, memory, processing power? Okay, so I think unit everyone is having okay. No one is having any problems in the sound, so I think you need to start. You need to check your output. Okay, so as for the optimization of code in terms of code lines, memory, processing power. So okay, so optimization can be done in terms of either processing or in terms of memory. So memory optimization is what we talk about, or it is time complexity. No, memory optimization is actually space complexity. So how much space does your program take at the runtime? So for example, if you have something which is, if you have an iterative process, or you have a task which is done via iterations, so you can either use loops, or you can do the same task via recursion. So if you employ loops, it would be less memory eating part. But if you employ, I would say, recursion, it would take more memory because of the additional stack frames, local variables, calls, and those things. Now, specifically talking about code lines, processing power, those things we can discuss in separate topics. For example, we can discuss those things in separate sessions where we can have the session on just standalone optimization. For example, like how to optimize your programs. I think that would do. As far as the basic or by default optimization goes in, GCC provides you, or I think most compilers provide you with default switches through which you can uh, enable what level of optimization do you want, right? So GCC provides you multiple options. O0 as the by default optimization, which is zero optimization. O1, O2, O3. I think O3 is the highest. Then we have something by the term OS, which optimizes for space. So it again depends on compiler version to compiler version. For example, my compiler version is 9.3.0, right? So let's suppose my compiler version was 8.1. So that happens when the compiler differences occur, the optimization algos differ, and therefore same options might yield or will yield different results in most cases, right? So those things are kind of dependent. If we are talking about the optimization in terms of compiler options, those things depend on compiler version, right? So let's talk about other things. So let's start with C, right? So starting with C, first question is why C, right? Because we all have different backgrounds, and in most cases we all have exposure to different languages. We all have done some Python, we all have done some C, C++, PHP, JavaScript, HTML, and basically any other language, right? The question is why C? And the simplest answer would be because I was interested in taking a session on C. I was not interested in any other language for the same reason, because I mean, why not, right? Another reason is since my primary purpose was to bridge the gap between the low level things which require you the understanding of system APIs, which are usually defined or exposed basically in terms of C. For example, the Win32 API, basically the native Windows API, or the Linux ABI. So the thing is, in most cases, operating system native tasks are usually talked about or implemented in C related functionality. Malwares are usually written in C or C++ for the efficiency and for the power reasons. You can write a malware in Python. That would be stupid because the sheer size of it would be 5 MB, 6 MB, 4 MBs, because it would have to bind its interpreter, and at the end of the day it is interpretation mechanism. So that is very bulky and nobody wants that thing. So if you are analyzing a malware, let's suppose you are doing the job of a malware analyst. So what happens is, at the end of the day, without decompilation feature or even with decompilation feature, right? So what happens is you are looking at assembly, and the system calls have definition or usage criteria in C or C++ in most cases. So you have to make a relation with how it would look in C. And therefore we are learning why C, right? Okay, so the question is, do you use C or C++? It depends. I use multiple languages. I have exposure to something around 15-20 languages. But again, exposure does not mean I can do every language very well. At a certain point, you do experience various things. For example, if I count the years I have experience of programming, I have been programming for last 15 to 16 years. So in those 15 to 16 years, I have programmed in around 20 languages. For some languages, I programmed 2 months. For some languages, I programmed 4 years, 10 years. And now it really depends on the job. If I'm trying to write a script which is going to do something on web applications or something else, I'm not going to write it in C, right? But if something is very well used or programmed through C, then I will be using C or C++. It depends, right? So text editors, IDEs, and compilers. Now why are we discussing these things? Because some people confuse text editors with IDEs and compilers. Yeah, for some reason it happens, right? Text editor is a program in which you will write your code. For example, let's make a directory C. Oh, okay, so we are in C. So a text editor is something such as this, which is basically, this is a notepad kind of thing. Kate is a text editor for Qt based sessions, or Qt.de for Linux. In Windows, we have Notepad as a text editor. A text editor is something where you write or you edit some form of text. In terms of command line text editors, we have Vim, V, Nano on Linux, right? An IDE, on the other hand, is an integrated development environment. So an integrated development environment is something which provides you a lot of tools for basically development, right? So it is a whole, and it is a whole environment. And by environment, I mean is, if you talk about something, let's suppose we are talking about Visual Studio. So Visual Studio provides you all the tools. It provides you autocomplete features. It provides you various other things. It provides you native environment. It provides you easy access to the APIs. It provides you build tools. It provides you debugging environment. It provides you everything, right? So that is the task of an IDE, to ease you into development and to provide a complete development environment. So you do not just type random text and hoping it would work or something like that. An IDE is a full blown thing, right? So I think I have code. Okay, I don't have code here. I had VS Code last time. Okay, we don't need any uh, IDE for now, right? A compiler is, I think you all you all are familiar with. Okay, Tushar raised hand. Yes, Tushar, can you please type, or should we unmute you? Let me see if we can unmute you. Okay, that was a mistake. कोई नहीं होता. So talking about compiler. So compiler is a program which will take your source code and then convert it to an executable. For example, since we are using C, so GCC is a compiler, and GCC is a GNU C or C++ compiler, which by default does is you pass it a .c file, source code file, and it will generate an ELF file for the operating system to execute. The basic task of a compiler is to turn the human readable source code into machine readable executable, which your operating system can process and can be directly executed by your microprocessor. Now let's start with the first C program. So let's start with hello, right? So I'm using Sublime Text here. You can use Sublime Text or anything else, whatever works for you, right? So printf. Okay, so let's compile it. To compile it, we provide the name of the file to GCC, and if you press enter, if there are any errors, they will be shown by GCC. Now, by doing an ls, we see there's another file a.out, which is the ELF file generated by the GCC. What we can do is, if we do not want the name is a.out, we can be like GCC hello.world and -o the output file name, which is hello, right? So we have two files, and let's see, both are pretty much the same thing. Let's run the hello, and it says hello world, right? So that is the basic first program of C, and I think everybody understands that thing. But the question is, what are the components of a C program? So a C program is divided into few or several components. Let's see what are those. Just a second. So this first part is called the preprocessor, but this is the preprocessor directive, and it will be processed by the C preprocessor. So why do we need stdio.h? So this is a header file, to be honest, right? So this is the header file, and we are including this header file as uh, the part of compilation, because the printf function is defined inside the stdio.h file. So to use printf, we have to include the stdio file. So before actually compilation, what happens is the C preprocessor will resolve all the preprocessor directives, and since it says include the stdio.h file, so it will include this file as a part of this program's code, and then we will have a reference to printf, right? So that way we do not have to use the we do not have to write our code for printf. Now, besides the preprocessor directives or preprocessor stuff, for example, that include files or header files, we can have multiple functions. For example, let's suppose we have a function 1, we have a function 2, and other things, right? So we can have multiple functions, but at the end of the day, if it is an executable, basically, right? So we are not going into complexities that some files do not have a main function, some files do, right? So every file has a main function. So the main function is where your program begins execution. So even if you have a function here that says function, and let's just say printf hello, it will not execute unless you call it inside main. So what happens is the execution of your program starts from main, and we are keeping it very simple, though you can call other functions and do stuff without main. but we are not going to get into those things for now. So we are assuming you do not know anything, and therefore we are not doing serious or complex, right? So this is what we have is, can we not have a main and manually mention the start point of the code? See, this is what I was talking about. We can do many things, and yes, we can have a program where we do not have a main function, and we can manually mention the start point of a code. But see, the point is, if we are starting with like what is C language and why are we programming C, let's not get into those things in the first session itself, right? I think you understand that, right? Okay, great. So below this header file inclusion, we have something what we call a comment. So a comment is something which either starts with a double lines or double forward slashes, or this way, right? A forward slash star, and it ends with forward slash star. So this is a C style comment, which is a multi-line comment basically. So anything besides this, anything besides these two characters or symbols is a C line C comment, until unless it encounters this thing, a reverse of these two characters. So anything between these is a comment, and anything, any statement or any data or anything, whatever you type in a comment, is not processed by the compiler, it is ignored by the compiler. So comments are used to tell information. For example, after this main function starts, right? So that is the job of comment. Now this is the C comment, or basically C style comment. So C usually supported, basically C supported the C line comment. This is a single line comment, two forward slashes, and this is a C++ style comment. So the problem with C style comments is that you need to specify this as the ending sequence. And in case you want to write a single line comment, I mean, this looks ugly in most cases, right? For example, see this. You can have this. We have these things in multiple things, multiple different source codes, like single line comments. But these C++ style comments, if we're talking about single line comments, these looks much cleaner, and therefore uh, we usually use these comments as well. If I'm not wrong, these were introduced in C89 or C99 proposal. So if we are talking about single line comments, then we are going to use C++ style comments. After that, we have main function. So this is the code. Anything between these parentheses, this and this, is the code for this function main. The structure of a function, let's say function structure, right? Let's discuss a function structure. So this is a function, and a function is a named block of code, and therefore these two lines are having the name main. No, we cannot use those things. Okay, so moving ahead, function structure. So a function is a named block of code. So if I want this uh, to be used again and again multiple times, so I can put this in a function. For example, let's suppose void function, and let's suppose void again, and let's just write this thing, right? So this is one thing now, and then I can call this function multiple times. So that would make me not do these, not write this functions code again and again. Now, if you have not programmed before, you might be thinking, why does it matter? I mean, you can write a single line so many times, right? But the thing is, we usually write functions which have a different functionality or discrete functionality. For example, let's suppose I need to write a code which reads a file, which opens a file, reads the data, and processes the data in some way so that it filters something, or it transforms lowercase characters into uppercase characters. And let's suppose you have to use that for 10 files. So instead of writing that code for 10 times, or writing that for one writing that code one time and then copy pasting it 9 more times, you write a single function and then you use that function. So that keeps the code clean, manageable, and therefore if any problem comes, you can easily debug that thing. So this is the basic structure of a C program, and this is the same thing that we will be following in all our session series, right? So this here was the printf function. Let's do, right. So printf function is the function that is used to print something on the screen, as you can see from its name, right? So this is the output of printf, and once that has been done, we have a return 0. So return 0 states that there was no problem in function execution, and once main returns, the operating system sees that main returns 0, everything went well, and the program exits properly, right? So that is the most basic uh, architecture, or I would say organization of a C program. I think that is clear, right? Okay, the question is it compulsory to mention return 0? I don't know what you are asking, because we can mention return 1 or return any other value, because see, the main function has a return type int. So we are not discussing the functions, because right now how to declare, define, and use functions, because we are going to use functions, or we are going to cover functions in, I think, second or third session. So till then, the thing is, we have said that main will return an integer, so you have to return something, and 0 is usually associated with no errors, and therefore we are returning 0, right? Okay, great. So that was this. Moving to the next topic, we have understanding the process of compilation. So the process of compilation is not a single step process, right? You do not just, do this and you get the file hello, right? What happens is there are multiple steps. So Sublime. So what happens is there's the source file, which is name.c, right? Any file which has a .c extension. You pass it to GCC to compile. First thing is preprocessing, which will process hash, include, and anything which is like, there are multiple things: hash define, hash if define, and like we are going to cover those things in another session. But the thing is, we saw this thing, right? Hash include. So this thing is going to be processed by the preprocessor. So first thing, preprocessor will process these things, and then once these have been processed, then the GCC or the then GCC will take on, GCC will do code analysis and stuff, and then we get an object file. And yeah, we do not directly get an object file, but it is the simplest explanation that we are having for now, right? We'll get into how compilers work, how the compiler will analyze the code, and then it will create something, then it will analyze, then it will create optimization, it will create an intermediate representation, and then after that intermediate representation there will be some assemblers and linkers and those things, right? So we are not going to get into those things. Simply speaking, first thing that happens is preprocessing. Second thing that happens is it produces an object file. So object files usually have .obj in their name, or .o if we are talking about Linux object files. These files are just simple assembly language kind of representation, which do not have any calls resolved. For example, if you are calling, if you're we called printf, right? So in the object file, the symbols are not resolved. Everything is there, but symbol resolution has not been done. So once the symbol resolution is done by the linker, this is where the linker comes in. So linker links the object file with the proper library, which will provide the code for printf, scanf, and other things, any other header files that you have mentioned and used. And then finally we get the executable file, which on Linux is a ELF file, and on Windows it is an exe file in most cases, right? So this is how the process of compilation works, and this is a very high level overview. There are multiple phases. I think pre-processing is a two-phase thing. Uh, the point, the compiler takes about 6 to 8 kind of different things, and then finally we get the object file with the help of assembler. And what that has been done, linker is invoked, and then the object file is then turned into an executable file. So this was a very high level overview to give you an idea that there are multiple things involved, right? So the question is where code goes first, stack or heap? Okay, look, stack is a different thing and heap is a different thing. Both stack and heap are used to hold data. Text or code is a code segment or code section, whatever you want to say, and therefore it has a different place. So this is what it looks like usually. So we have text, actually, yeah, let's just have it stack. Then so there are various mappings. It can be stack, it can be any of those things, right? Then here's the heap. So stack grows downwards and heap grows upwards. Then we have BSS, we have data, we have text. So this is where your code resides. This is where uh, global data resides. This is where global uninitialized data resides. This is where you get malloc, calloc, reloc, and basically any other dynamic memory allocation part. This is where your local variables, for example, int x, int y, and whatever, if they are inside a function scope, right? So this is how it all works. So stack is defined, allocated according to the code, like the space for variables. Heap is for dynamic allocation. Yes, heap is used when you use functions such as malloc, calloc, reloc specifically. Stack is used by default, for example, to hold local variables, to hold return addresses, and to hold various other kind of things, right? So mostly it holds just these two things. Another thing is anything which is related to execution of the function is also stored on the stack, and therefore a stack holds various things. To see the real-time memory organization in Linux, we can have this thing. So the proc file system, cd proc. So proc file system holds the data about execution, and each folder, as you can see, is mapped to a PID of the process ID. For example, PID 1, this is the PID 1. I don't think we can go into one. Okay, we can go into one. And no, we cannot read things because permission denied. So instead of doing all that part, let's try to read proc self maps. So once we see what the output is, we will be looking at, I will be explaining how it works, right? So we see some output, and let's first explain what we did here. So I did a cat on this file, proc self maps. So self is anonymous, is the same as which process invoked it. And since we use the cat program, so we are going into the process ID of this process, which was created as the result of this command, right? So, and inside this, we have a file by the name maps. So what this maps file does is it holds program mappings or segment mappings at the runtime. Now, as you can see, we have these are the memory addresses. This is the start address. This is the end address. This is the permissions. This is, I think, size or something. I don't remember what this is. And this is the name of the binary section or something which is mapped, right? So you can see this cat. So since we invoke the cat program, we have 5 uh, mappings, and each mapping is of a particular size. So it starts with this, ends on this, it starts with this, ends at this thing. So, but the thing is, there is only one executable copy of bin cat in memory, which is this one, because it has the X or the executable permission. The rest of the copies have read permission, and this copy has a read write permission. So this must be for some data which can be for some section which can be readable and writable in memory. And you can see this is the heap mapping. So the heap is mapped from this to this. Then we have some local archive mapping. Then we have libc mapping for the code of C library. Then we have some anonymous mappings, which no idea what it is since there is no information available. Then we have some runtime linker mappings or interpreter mappings. Then we have another anonymous mapping. And this is where it gets interesting. This is the stack. So you notice the address of the stack is, let me just copy it. Yeah, yes, this. Yeah, so the stack is mapped, unfortunately. So this is the stack address, and the heap is this address. And the reason being, stack starts from the top and it goes to the bottom, whereas the heap is somewhere in the middle. And if you talk about the text section, which is here, right? So this is the text section, or this is where the code is mapped from this address to this address. So code is at the lowest, I think. Yes, so code is at the lowest in this scenario because this section only has read permissions. So it might be some other section of the binary itself. So this binary is mapped as 5 different sections, but really no idea why, where a particular section is in this. The data section will have, of course, readable and writable permissions, and the BSS section will also have readable and writable permissions. So these are these two things, most probably. We have 3 sections which have only readable permissions, and therefore those might be some other sections or some other informations which was mapped along with the binary. Now, for our practical purposes, this is the lowest in memory. This is data and BSS, which has read write permissions. Yeah, right, because some global information might be readable and writable. So there's that. Then after that, we have heap, and on the top, we have the stack. This is the basic organization of the memory, in memory representation of a executable, right? So I think you understand the point. Okay, great. So moving ahead, compilation versus interpretation. So we have all been exposed to Python or Ruby or PHP, which are basically interpreted languages. And the C, C++ are examples of compiled languages. So there are multiple kinds of languages. If we talk about, basically we have compiled, we have interpreted, and then on the top we have assembly, which is basically you assemble it, then you link it, and then you get the exe, right? Compiled is compile and get the exe. Interpreted is you get nothing, because you have a file, for example, name.py, right? So when you run the name.py as python name.py, you do not get any file which you can run. I mean, you can compile it and you can get a Python compiled file or something else, but that is not the point, right? So the interpretation, what interpreted languages do is they have an interpreter, or the interpreter does is interpreter takes every single line, execute it inside the memory, and moves ahead. And let's suppose there was an error in this line in interpretation. So this all will work fine. There will be an error on this line, and once you fix the error on this line, then it will move next. In case of compiled languages, what happens is the compiler reads the whole file at once, right? So it will read the whole file. It will report whether there are no errors, or whether there is one error, or whether there are two errors, 10 errors, or something like that, right? Once you have done all that, the compiler will finally get you an exe. So what is the actual difference? I mean, the difference in terms of execution speed is what we are talking about. So who returns errors? Interpreter itself. Yes, in case of an interpreted language, the interpreter will return the error and tell you that there has been an error, right? For example, let's see this as equal to hello, and since Python is not Python strings are immutable, let's just do this. This error has been returned by Python interpreter, right? So let's exit this. So the advantage of compiled languages over interpreted languages is that you get an exe, and then you do not need the compiler again, right? You can pass the exe or the executable on the same platform. For example, if it is in Linux executable, you can pass that executable to anyone who has the Linux, and it will run without any problem, as well as it will be fast because you do not need to process things one line at a time, right? You have already turned it into a machine executable file, or the file which has executable data, machine instructions, and therefore compiled uh, objects, or the exes, are usually much faster in execution in terms of interpreted languages, right, or interpreted scripts. So that is the basic difference that we have to take care of, right? Now, understanding the C philosophy. So this is the one of the most important things that you have to keep in mind during the whole sessions. Let's just have this. So the C philosophy states that keep things simple, right? So C is a very small language, to be honest, right? So there are tons and tons of things in Python, C++, and other languages, but C is actually a very small language. So keep things as simple as possible. Second thing is uh, you are responsible for what you want to do, for what you want to do. For example, you want to shoot yourself, right? For some reason, you are so stupid that you want to shoot yourself. So C will not complain. C is like, go ahead, do it, right? So C will give you the gun and you can go shoot yourself. That is the point of C. And this changes the burden, right? So what this does is, now you are responsible. You must know what you're doing. And this is where most people have problems with, right? So most people do not understand how pointers work. Most people do not understand a majority of things, right? And then they're like, C is hard, or like this should not be possible, or whatever this is. Like, if you do not know what you're doing, then C is probably not for you. You should be doing some other languages, for example, Python or something else. For example, you have a pointer, right? And your pointer is null. Let's suppose you want to do is, no, there are like hundreds of methods to shoot yourself without even using pointers, but at the end of the day, pointers is one of the easiest, right? So let's suppose you set a pointer to null, and then int x, and then you want a value from pointer, but you do not know it is null because you were lazy enough to not check the value of pointer, and you just read the value from that pointer, from that location into X. So what do you think will happen? Now, one school of thought says that you should not be able to do this because there would be some error and you should not be able to dereference the null pointer. But what C is like, you must know what you're doing. If you do not know what you're doing, then well, at the end of the day, it is your fault, right? So, yeah. For example, one of the most common things is that people confuse with is array indexing or the problems with array indexing. For example, you have an array of 10 objects. God. Yeah, so you have an array of 10 objects. But what you want to do is, for some reason, you access 12th, 15th array, 15th element. Now the thing is, well, it is your problem. You are accessing 15th element. The way how C handles arrays, or the way how arrays are represented and used inside C programming language or through C programming language, it is perfectly valid, right? So this statement is valid. It is actually as valid as this statement is, right? These two statements are exactly the same thing, right? So this is where most people have complaints with, because Java will say it is an out of bound array access exception, or array out of bound exception, which is the technical name. Python or some other languages where, right, the point is, in most languages where you have some safe mechanism, they throw an error. But the point is, C says, I trust you what you're doing. So if you are accessing array 15 or 15th or 16th element of the array, then maybe that's what you want. So go ahead and do it. And this is what makes it so simple, right? So it is just super plain. Right? It is as plain as something can be. And this is the best part of C, right? And it takes a lot of time and, I would say, effort and understanding to see why this is the best part. Now we will see why this is later, but these are the basic fundamentals of the C philosophy, which are not really seen in other languages. For example, talking about the pointers, right? A pointer is something which points to a location, which points to an address, basically, right? Or which is an address which points to a variable or identifier, a value, whatever. Now, if you are carelessly pointing it somewhere else, or if you are using a pointer which you should not use, or if you are using a pointer which has already been freed, then, well, that is your problem, right? So this is why most people hate C, but I mean, at the end of the day, it again boils down to simple preferences. Some people like it, some people do not like it, right? So this is what I want you to understand. So we will be having multiple things. For example, how array accesses values, how strings process values, how pointers work, how you can pass pointers to different things. And if you mess something up, if you do something wrong, then yes, things will break and you will definitely be complaining. So this was in advance to tell you that there are going to be things which are going to be problematic, right? Where we define pointer inside or outside main function, we can define pointer anywhere, and that's the whole point. C says you can, well, if you want to do something, I will help it, right? So you can define pointer inside a function, you can define pointer outside a function. Anyways, let's start with actual programming. Data types, variables, and expressions. So the first question is, what are data types? So a data type is something that is used to represent a chunk in memory. This is one of the most simple, this is the simplest definition that I would say would be, right? So a data type is loosely used a term to tell you what operations are available on something and how much memory is it going to use. For example, let's again start with this thing. So data types. So a data type tells two things basically. One is size of memory per element, and another is operations which are valid or which are permitted on that data type. For example, integer is, as you can understand, is a number, right? So integer is a number, and therefore the size is, again, size. We are going to talk about sizes. Size is usually 4 bytes, and operations are, what are the operations that should be allowed on integers? Well, plus, minus, multiply, divide, and we have another thing which is the modulo operator. So this is modulo, or the remainder operator. It tells you, if you divide something by something, how much remainder would you get. For example, if you divide 10 by 3, you would get 1 as the remainder, right? Because 3 into 3 is 9 and you get 1. So these are the basic operations that should be allowed on integers. However, let's suppose you have something else. For example, you have a pointer. Now, pointer is a data type, perhaps, right? Pointer, the size is size of an address because it holds an address, and therefore it must have enough room to hold address. And what are the operations that you can have on a pointer, right? So it does not make any sense to add two addresses because a pointer is essentially an address. You cannot multiply two addresses, right? New Delhi into Mumbai does not yield anything, right? You cannot divide two addresses, so that is again stupid. Of course, there's no need for the modulo. But what you can do is you can subtract some addresses, right? Subtraction. But why is subtraction allowed? Because to see the difference between the two distances. Int size is 2 or 4, right? So the thing is, integer size, or the sizes, are usually defined by the compiler used. But standard is, in C there are very less standards, right? So what you can do is, we have something by the name size of. So printf size of int is, let's just %z_d, right, bytes. And we can see the size of a data type by using size of. And I mean, if you want to see the size of int, you can do this. So what this will return is, it will return a number which will tell you how many bytes are going to be utilized by that data type, right? So let's see, integer, character, right? So integer is one thing, and we have a short int, we have a long int. These are the integer to represent something, to that we can use floating point numbers. Or okay, so see, the thing is, the session is going live. Session is streamed live on YouTube, so you can check anytime whenever you are comfortable with it, right? So integers, to process integers, we have three things at the very least. So there's an integer, there's a short int, which is usually 2 bytes, right? Then we have a long int, which is usually 8 bytes on 64-bit machines, or 4 bytes on 32-bit machines. Now, to deal with numbers that contains decimal point, which are like, for example, 4.2 or 56.8, right? So to represent these numbers, or to use these numbers, we have float and double, which is basically a double float. So float is of 4 bytes, double is of 8 bytes, and we have something long double, which is of 10 bytes or 16 bytes. We need to check that thing, right? YouTube link is, it was passed in the email, I think, or you can.
I will be sharing it after a session.
Okay, sure. We will share it after the session. Okay, so these three things are for real numbers. These three things are for integers, right, or whole numbers, whatever you. Yeah, we can do these ones. And besides that, we also have something which is char, or a single character, right, to represent a single character, which is a single byte. Now, to tell you the answer of size differences, so sizes are defined by the compiler. Uh, Another thing is, well, sizes are not really fixed, to be honest, by the standards. For example, a character is a single byte, which is NSI standard size, right? So ANSI standard, ANSI size of char, initially used, which initially used 7 bits because, well, it was English only. Then they moved to 8 bits. So this is the NSI size of a character. A short is, now see, the definitions are kind of like this. An integer is about 4 bytes or something. A short is less than or shorter than an int, but at max it can be the size of an int. Long is at the very least as long as int, but it can be bigger. So the definitions are kind of weird in this thing. So to see what the sizes of objects or data types are, so we are going to do this thing, int, then let's just have a short here, right? Short, then we have an int, we have float, we have double. Okay, I forgot long. We have long, and then yeah, we have long as well, but you get the point, right? So double, and let's just say long double, right? So char, short, int, long, float, double, long double, right? So this is what we're going to see. This is C minus O, hello. And yeah, so character is 1 byte, short is 2 bytes, int is 4, long is 8, float is 4, double is 8, and long double is 16 bytes in size. And these are the results on my 64-bit Linux system. On 32 bits, long will be 4 bytes in size, and this would be, I'm not really sure on a 32-bit system. Let's see what would be the size on a 32-bit system. Okay, so by using the minus M32 parameter to GCC on a 64-bit machine, we compile the code as a 32-bit code, right? So you can see in 32-bit code, we have integer and long, both 4 bytes, but on 64-bit code, integer and longs are 8 bytes. So the sizes are not fixed in stone, right? There are no standards which says like an integer must be 4 bytes and the long must be 8 bytes. We do not care about that machine is 32 bits or 64 bits in size, right? So it really depends on the compiler and the specifications. I think you get the point by now. Okay, so the question is, which primitive and non-primitive data types are supported in C? Okay, so we have two types of data types. That is a good question. I forgot to tell you about primitive and not primitive data types. Primitive data types and non-primitive data types. So a primitive data type is basically what we have seen right now, right? So this is a basic data type. A primitive data type is the fundamental type of data type. A non-primitive data type is something which is a collection or an aggregation of the primitive data types. For example, a class, if you have heard about object-oriented programming, a class is a example of non-primitive data type. Or in C, what is structure is a non-primitive data type. Union, string, though there is nothing by the name string in C, we have a character array. An array is again a non-primitive data type. So a non-primitive data type is something which is not provided by default but can be created by you. I think the answer is clear, right? Okay, great. So what is the point of using data types? We learned what data types are, but what is the need for data types, right? Why do we need like three different types to represent a single number, right? Or three different types to represent a decimal number? And the answer is there are various things. Okay, could we say non-primitive are derived from primitive? Yes, non-primitive data types are derived from primitive data types, and that is why they are also known as derived data types. I think I might be wrong, but as far as my understanding goes, that is the thing. So now the question comes: why do we need three different data types or three different sizes to support a single number, which is a whole number or an integer? And the answer is it depends on the situation, right? Let's suppose you have size constraints, or you have either size constraints on the program memory, or you have size constraints on your input. For example, let's suppose uh, you are taking age as input, right? So your input is age. So it does not really make sense to have a for an integer by default, right? You can have an integer as a most cases people do, but think about it, you do not really need this thing. Age can be between 0 to, let's say 0 to uh, 100, let's say 120, right? So this can be the bracket, let's say 150. I don't really think anybody lives more than that. So you can represent age as the character only, right? So what that will do is, if you represent the age as a character, and let's have uh, a difference as an int, right? So difference would be it takes 4 bytes and it takes 1 byte, and therefore uh, the limits come in, right? So a character will be between 0 to 255 if we are talking about unsigned, which is basically negative positive, right? So 0 to 255, I think. Yeah. Okay. I'm getting too mathematical here in terms of symbols, but yeah. But whereas in terms of this would be between 0 to 2 raised to power 32. Yeah, minus 1. So you do not really want to have this much size for your input of age when the input of age fits perfectly between this thing. So you save 3 bytes and operations will get restricted only on 1 byte. For some operations, 1 byte is more than enough. For some operations, you need 4 bytes. For some operations, you need 8 bytes. And for some operations, you need more than 8 bytes. And therefore, we have different data types to solve those things. For example, a float is basically precision up to 6 six place after digit, after decimal, sorry, after dot. But if you need more than 6 places precision, so you use float, which gets you up to 14 or 16, if I'm not wrong. 14 would be the point, I think. I'm not really sure, but the point is, if you need more precision than 6 places after the dot, use double. And if you need more precision and you need higher values, then you can use long double, right? More precision. And this is the difference, where the difference between different data types that hold the same data, right? I think we understand that thing, right? Okay, so let's move ahead. So type modifiers. So we learned about what data types are. Let's talk about type modifiers. So a type modifier is something that modifies uh, type modifier is something that modifies the behavior of that modifies behavior of data type, right? For example, by default, each of these data type has negative and positive values, positive representation. For example, integer, or let's suppose character. A character holds values between uh, minus 128 to 127. Short would be uh, sorry, minus of 2 raised to power 15 to 2 raised to power 15 minus 1. So the point is, if you do not write anything, or if you just use an integer or a character as it is, they can store negative or positive values. But if you only want, let's suppose you only want positive values, for example, talking about the age again, right? The age cannot be negative for a person. But how do you restrict, or how do you tell your program that do not take a negative number, or do not process a negative number, right? For that thing, what we have is a type modifier, which categorizes things as unsigned and signed. So signed numbers are negative and positive by default, right? So a signed number is something which can be negative or positive, whereas an unsigned number is something which can only be positive. So to, let's suppose you want to, take age as an input, so you will use unsigned char and then age. So what this will ensure is, this ensures that age will never be zero, never be zero, and well, it can never be more than, it can never be more than 255. So this is what it ensures, and this is why we use type modifiers. For example, you only need positive numbers, so just tell you just write unsigned before that data type, and then it does not contain negative values, right? Hope that is clear. Okay, so moving ahead, need for variables, or what are variables? So a variable is something which is used to hold a value. For example, a variable is something that can change, basically, and it holds a value. For example, int age is a variable where you can store an age, where you can store the age of a person, right? Let's suppose initial value is 15, then you increment it because there was a birthday, and then it gets 16. So this is what a variable is used for. It is a named uh, location for an input which can be used. In most basic sense, yes. So let's see this all as an example, right? So Sublime vote.c. Regex is supported or not? Yes, regex is supported, but you have different header files for those things. So you need to include the proper header file. So let's write a program which just takes someone's age as the input, and then it checks whether they are eligible to vote or not. So let's just say int age printf enter your age. So printf function is used to print something on screen, as we have seen, right? And to take input, we are using scanf. There are multiple functions that can be used to take input, but scanf is most common and it works perfectly fine. So until unless we need something which scanf cannot provide, we are going to use scanf, right? So scanf works pretty much like printf. So to take this input as an integer, we are going to represent use %d, and we're going to pass the address of a variable where we want to take the input. So age, and what this does is this provides the address of this thing. So age, when we write age, we mean the value inside this variable, and when we prepend it with an ampersand, we mean the address of this variable, right? So printf, okay, you are %d years old, and that is the basic idea. So we're just taking the input and printing it back in. GCC what.c minus o what 15. See, I'm 15 years old. Now to demonstrate the point that we were talking about, the sizes as well as uh, the type modifiers, let's see what happens. And this is where the point of proper programming comes in, right? So let's say my age is -20. Now I'm -20 years old. See, this should not be possible because nobody can be -20 years old. And this is one thing. Another thing is, let's suppose I am 256 this years old. I'm not supposed to be this many years old, right? And that is the point. So to enforce these things, we have to see this, right? Unsigned care. And to do this, we have, I think, okay, I think this is the point. Yeah. -10. I'm 246 years old. And I'm 0 years old. And let's suppose, and see, I'm not this many years old. Now this is the phenomenon, or this is the thing, why -10 got converted into 246 is because, well, something called things, I mean, how do I explain this thing? Okay, so I would give this as a homework to figure out why -10 when passed to an unsigned value of a character gives you 246 and not something else, right? So that would be one homework. Now this was the basic fundamental idea of taking input and printing something on screen, as well as using variables. Are those ASCII values are output ASCII values? Which values are you asking about? Everything is ASCII here since, okay, so this is all ASCII, right? So this is all ASCII. Now one question, -10 is for -10 is 246. Okay, so -10 is also an ASCII value, and 246 is also an ASCII value. So you have to see by yourself why that is being turned into 246. In the next session, we are going to cover that. And in case you have the doubt, in case you figure out, we can take that before the session, right? So this is, consider this as your homework. Now, one question: I have been taught C in my college, but most students, including me, think C is outdated. But when I see projects on coding and other people in this, okay, how can I improve my programming skills and make it more interesting? Because most of the time we are writing code. Okay, so see, the thing is, C is not outdated. Majority of things are still coded in C or C++, right? Now, some people might differ, but mostly C or C++ is pretty much the same thing, right? And when I'm saying C or C++, C or C++ is the same, pretty much the same thing, the reason is they are pretty much at the same level of complexity, or uh, in the hierarchy of programming languages, right? They are both high level programming languages. They are not very high level programming languages, and they are not middle level or low level programming languages. So those two languages are pretty much the same thing. Those two languages target pretty much the same base of softwares. For example, native softwares are usually programmed in C or C++. Web browsers, C or C++, mostly C++, because C++ is for very big tasks. C++ is pretty easier to code with. C becomes, at times C becomes a bit, I would say, hard to manage, because C++ provides a lot of libraries and stuff, right? So C++ has a little bit advantage over there. Now, okay. Now another thing is, so so C is not outdated. Operating systems are still written in C. Linux is written in C. Windows is written in C. Drivers are still written in C, right? You create a new driver for Linux, or you create a new driver for your Windows 10 system, you are going to write in C or C++. The thing is, it is not outdated. Games are programmed in C or C++. Game engines are programmed in C or C++. A majority of code is still in C or C++. Things are getting programmed in C or C++. It's just people have a really different mindset. For example, in colleges, they propagate the thing that Java is the best and everybody requires Java. When the thing is, the professors who claim that Java is very good, they do not seem to be able to explain why Java is that good, because Java sucks, to be honest, right? Java is very bad. Now, majority of professors have not done any job in terms of actual professional sector, right? They have not been parts of projects, they have not developed programs, they have not worked on other things. They have just did their BTech, did their MTech, and then they are teaching for last 20 years, and then they're like, nobody uses C. No, that is not the point, right? As for any suggestions for beginner project, see, any project can be a beginner or intermediate project. Think of something and just try to write it in C or C++, right? That should get you started. We can do other things as well, right? So once we progress in this series, you will get many ideas, and if you want to, wait till then, that would be much better. Okay, so the question is, how a negative integer is stored. Okay, let's have this as another homework, and in the next session we will be talking about how a negative integer is stored or a positive integer is stored, right? Now, okay, so we still have some time. I think we will need another half an hour at least. Yeah, we will need another half an hour to do this thing. And in the next, in this half an hour, we will finish this thing. Now, name variables, right? So we need a name for a variable, because let's suppose you want to store 10 things as a program. Let's suppose you want to store the data of student. So for student, name, age, gender, roll number, current year, section, and let's suppose aggregate, right, at this uh, aggregate marks till this point. So you have a lot of things. So you need this many, at least this many named locations, so you don't mix up with. So first thing is you need to store these things. Second thing is you need to access those things. For example, let's suppose you need to print the name of a student. Until unless you have something which directly points to the name of the student in your input, you cannot do that thing. And therefore, you need to properly name your variables and use those variables properly, right? Now, variables are called identifiers in C, right? So identifier is the proper word, which basically identifies something. In most cases, it is an input. For example, the name, the name identifier, you can write it as name. Uh, in the program, we saw age, right? So this is an identifier. Now, the rules are pretty simple. You cannot have something which is having a single or a double underscore, because usually those kind of usually that style is restricted or not allowed for you to use, because a lot of internal C library functions or global variables use that kind of style, right? So it is better to not use a single uh, underscore or double underscore, and keep it simple. Another rule is keep your identifier names or variable names as descriptive as you can, because let's suppose this is a big program. So even if how big the program is, I see a variable name age. What do I expect? It it should contain age or something like that, right? But let's suppose we have A, B, C, D, E, right? Let's suppose we have 5 different variables, and the function is, let's suppose, 100 lines long. Now, what would I understand? Like, what does the variable A means, or what does the variable B means? Right? It does not mean anything, and this would really complicate things if you are even trying to understand your own code. Let's suppose 2 months from now or 3 days from now, when you are getting into an error and you're like, I do not know what C is, and then you are really scrolling up and down again and again to make sense of it, what C means and what D means, and why you did not write those names properly, right? So it is always uh, suggested that you use proper names. For example, gender, you can be like gender, roll number is uh, roll number, year can be year, section is section. So the point is, even if someone else takes a look and, sorry, the spelling is gender is wrong. Yeah. So even if someone else takes a look at, okay, the variable name is gender. So of course they will get to know what the variable means. And even if you are debugging something is crashing, you will know what a certain variable holds. So if a certain variable holds a different thing when it is not supposed to hold that value, you will see what the problem is, right? So this helps in debugging. It helps in writing clean code. It helps in maintaining code. Let's suppose you were working for a company and then you leave the company, the code is passed to someone else. So the person can also understand and modify it properly. Or you create a project and then you open source it. So people who are using it, who want to understand it, can understand it properly. So variable names should be properly used or written, right? Chosen. Now we have covered all the kind of basics theory, and this was a little too much. It took us more than 90 minutes to cover this much theory. Now let's move to programming. So till this point, we have seen basic input output, basic input and output. The reason to take output is usually by printf. Input as we are using scanf, right? So this is what we're going to do. Now, coming back to the question, right? We have what.c. So let's suppose the task is to check the validity of voter. If less than 18, decline, else he is allowed to vote, right? So basic idea. Now this kind of thing, or this kind of functionality, requires you to make a decision. This kind of functionality requires you to have the ability to code, or so not the code, the to make decisions, to compare things. For example, you need to compare the age with whether it is less than 18 or it is more than 18, right? And for that we have multiple options. First and the simple most is the if statement, and if statements works as expected if something is true, right? So if something is true, if age is greater than 18, we will print you can vote, right? So this is uh, the simplest thing, which is vote. And let's suppose my age is 21. Okay, sorry, my age is 21. Yeah, so I can vote. I'm 21 years old and I can vote. Let's suppose my age is 10. I'm not allowed to vote. Now, in this example, we saw that if we pass a criteria, we can do something, but we did not see what if. Let's suppose you want to print or you want to take an action if this statement is not true, right? So that is where the else part comes in. If else, so printf, you cannot vote. Check again, I can vote. And if my age is less than 18, I cannot vote. The most simple and the most fundamental method of decision making is if else. Now what you can do is you can also make multiple decisions. For example, you can have various blocks of else if. uh, okay. So let's suppose you want to say age is uh, greater than 65, right? So printf, you are senior citizen, right? So what happens is we are comparing multiple things. So first thing, we are checking whether the age is greater than 18. If the age is greater than 18, the person is allowed to vote. Then we are checking if the age is greater than 65, then the person is also a senior citizen, right? So we can have different functionality based on that thing. And if neither of those things is there, then the person cannot vote, right? So compile it again. Vote 21. Yes, I can vote. And let's suppose 66. You are 66 years old and you can vote. Okay, this is problematic. It should not be there. I don't think this should be there. It should be like you are 66. I can vote. Yes, but I should also be able to print this thing. Okay, so in case something does not work properly, another method can be is I do not really want to extend the session too much because we originally planned it for 90 minutes and it has already been about 2 hours, right? So instead of this, instead of else if, we can have nested if else. So if we can also have if inside this, if age is greater than 65, printf, you are senior. Let's just see if it works. Okay, great. So what happens is we can, so this thing is called as nested if or nested if else. So I can also present an else here, which would be printf, you are not senior, right? So because your age is not greater than 65, but your age is greater than 18, so you can vote, but you are not a senior, right? So let's suppose 55. Now you can vote, but you are not a senior. So this thing is what we call a nested if else, where you have an if else or if inside another if else. So this is the nested if else approach to do things. Of course, you could have done that with a single if else or even an else if. I don't know why that is not working for now, but we will see later, right? So this is one thing. Another method of making decisions is a switch case statement. So a switch case statement is much like an if else statement, but what happens is in case of switch case statement, you need to be very precise, right? You cannot compare things, but you can make cases. For example, sublime switch.c. So int age, let's just say char vowel, right? So let's just see if the user enters a character, enter a character. Scanf would be %c to take a character as an input and pass the address of the input variable. Now, so we will see if it is or the input is something which exactly matches or not. So in case of switch case, we have switched on the input which we are talking, and we are going to do a case. So a printf vowel, right, break. We have five vowels and a e I o u. Default is a case which does not uh, match with any case, and here we will print it is not a vowel. And after the default or any of these break, it will jump out the switch, and let's just print switch ended, switch ended. Enter a character, let's suppose q is not a vowel and switch ended. Okay, so I need to print a new line here so that it gets different. Yeah, so q is not a vowel, right? But let's see what happens if I is a vowel and switch ended. Now, the difference between if else and switch is, the first thing is, well, why do we need switch, right? So we could have achieved the same thing or the same comparisons with if, but we would have to do if vowel equals to a, then this, if vowel equals to e, then this. So we would have to write 5 different if, and then there would have been an else. So we would have to, do so much. In case of vowel, since it was direct equality comparison, so we just we did not need to write that much lines of code. This is the switch case, and the problem with switch case is you cannot check. For example, you cannot check whether vowel or some number is greater than or less than something. You cannot perform comparison operations. So what case A equals is, this would directly translate into if, not directly, but kind of equally, right? So if vowel equals to A, if vowel equals to A, then print, that's a straight vowel, right? So this is what it is. So you can assume this statement is pretty much this statement. Okay, can we use array for single case and make the code little more less like in a single case? I did not understand what you mean by array for a single case and make the code little more less. Uh, no idea what you are asking, seriously. Maybe if you want to, if you can write using an array and print, message it as a group chat message, we can see, because uh, I have no idea what you are saying. So till then, till okay, case AIOU. No, this is not how it works. This is the only syntax of using switch case. I mean, you switch on something, and then you specify a case one by one. So this is the actual syntax, and this is how you have to use it. I think that is clear, right? Okay, great. Now, conditional operator. So conditional operator is kind of a hack, I would say. A conditional operator is more like, I need to see how the conditional operator works. Right. Let's just have the conditional operator right here, and int value. Right. So let's just have printf enter a number. Right. Scanf, take integer as an input. We use %d, and then we take the address and go right. So this, okay, sorry, unfortunately I wrote the wrong one. Well, right, so we are taking the input as the value. Now in this we are moving to, so what we can do is we can either compare using if else, or we can use switch case if we are trying to do the equality operations or equality comparisons. Now there's another thing that is true, that can be used for comparisons, right? So that is the ternary operator. So ternary operator. Now how that works is, let's suppose we want to check if value is greater than 10. So that is the condition, and yeah, so that is the condition. So this signifies the start of the, this is the comparison part. Now the first part is, this is true and this is false. So this is where we write what happens if the point is true. So we are going to write printf, I don't think it would work that way. Yeah, true, right? Or in case of false, let's write printf false, and let's see if this works or not, because I'm not really sure, because I do not really use this ugly syntax. Switch a, enter a number, let's say 10, and yes, it works fine. So yeah, so here we are. Now what happens is, if the value is greater than 10, it will print true. Let's just pass this test, and let's suppose the input is 12 and it says true. So we could have written this single statement as, let's just have multi-line comment to show you what we could have written it, and we could have done it if value is greater than 10, um, printf true, right? Then else printf, it would have been false. So we This, I would say, 5-line code has been reduced to a single line code. And this is the ternary operator. The name is ternary because it takes 3 parameters or 3 different things. This is the condition, which is tested whether it is true or false. If it is true, then this part of code will be executed. If the result of this statement is false, then this part will get executed, which if you want to write it in as if else, this would be represented like this. And since it is a comparison operation, you cannot write it as a switch case statement, right? I hope this is clear, right? So these were the these were the few different things that are used in decision making in C. So which gives you or which provides you the uh, power to test whether something is true or false, and through which you can test whether something has been successful, something has not been successful, and things like that. So we have covered decision making in C. The last thing that is required for today is looping in C, right? And the question is, what are loops and why do we require loops? So we have covered a fundamental question. We have covered various fundamental questions. The first thing is how to take input output. Second thing is how to make decisions, right? Whether what to do if something is true, or what to do when something is false, right? Uh, Now, once that has been done, we move to the functionality where we want something when we want to, we want to execute something multiple times. For example, where you want to run something 100 times, run a code 100 times or 1,000 times, or unless user enters a specific input, right? Till then, just keep asking the same questions, right? Unless the user says quit, just keep asking the same questions. So this thing is the repetition again and again is what we call a loop. So a loop is, for example, A, B, C, and after then C, you want to again move to A, then B, then C, then again A, then B, then C. Basically, until unless you want to exit. And since we already decided how to make, we already learned how to make decisions, well, you can always decide like when to exit out the loop. Now, the use of loops is, again, we just talked about, right? We sometimes we do want to require the facility. For example, let's suppose a better example would be, let's suppose you have a record of 100 students and you want to um, you know take the name and write it to a different file for some purpose, right? So you need to write a loop. You need to write a loop that will run 100 times. You need to write a loop that will run 100 times so that this task can be done. So the question comes is how to write a loop, right? How to write a loop. And to write a loop, we have certain things. For example, we have a for loop, we have a while loop, and a do while loop. So let's start with a for loop, right? So let's just have a looping. Okay, so should we continue it today or should we cover the loops tomorrow? Because I don't think people are paying much attention, and I think it has been really tiring experience. It's already been 2 hours, right? So what do you want? Should we cover it right now or should we cover it tomorrow? I mean, in the next session. Cover it now. Okay. Okay. So let's just cover it now. Let's finish it. So let's suppose uh, hmm, Okay, great. So there are two people who are saying today. Loop.c. Int number. So let's define the objective. So take a number. God, I hate this keyboard. Take a number as input and print all the numbers from 1 to that number, right? And the second would be another objective, add all the numbers from 1 to that number, which if you know a little maths from class, I would say 10th or 8th, sum of n numbers from 1 to n is n minus 1 divided by 2, right? So the first thing is we are going to do this thing, and once we accomplish this thing, we are going to do this thing, right? So we are going to take a variable as a number and printf enter a number, scanf %d number. Now at this point we have taken the number as an input, so we are going to use for loop. So this is the structure of the for loop, syntax of the for loop, to be honest, right? So the for loop starts with, for loop has three things, and let's just expand those things. For initialization, condition or comparison, let's say comparison, which is basically the exit statement, to be honest. I don't really remember what is the case. And this is the update statement. So initialization is the initialization of the counter, and in this case the counter is I. The counter is something that will count how far we have reached the number, right? Because we need a number which will tell whether we are at 1, 2, 3, 4, 5, have we counted till the number that has been input, or uh, have we gone ahead, because we need something to tell us whether we have reached the number, how many we need to print or not, right? The basic idea. So this is the initialization. We start with 0 and we are going to count till number -1, but since we have to cover from 1 to that number, so we are just going to do 1 and less than or equal to, less than or equal to number and plus plus I. So update statement is to update the counter. So at every single loop iteration, for example, let's suppose we have 3 statements here. So in after these 3 statements, when the loop moves again, it checks whether it has been true or not. I mean, after this, what happens is the update statement executes, and then the condition is checked. So we need to update it again, right? So this mechanism, the update statement, ensures that the number updates by itself and we do not have to increment it again and again. Okay, yes, I can speak about post increment and pre increment. Okay, so these things is getting seriously complex. Just a second, let me just keep it properly here. So there are two things. One thing is post increment. I mean, let's just not do this here. So one thing is post increment and one is pre increment, right? So post increment, so increment is right, something plus 1 is basically increment, right? Now this is increment. So what do we mean by post increment? So post increment is uh, the operator plus plus is used. So let's suppose count plus plus is the post increment, and plus plus count is pre increment. At the end of the day, both means count plus one, which is of course going to be updated inside count. So count equals to count plus one, and here again count equals to count plus one. The difference between post and pre increment is, let's suppose 7 plus let's suppose count is 5, for example, right? So let's suppose we are doing 7 plus count plus plus. Yes, so this is the post increment. So what this will expand to is it will get 7 plus 5, which will result in 12, but sorry, 12, yeah. But what happens is, since there has been a plus plus, so in case of post increment, the value of count will be used, and then this count equals to count plus one will get executed. So at the end of this statement, what happens is uh, the result is 12, but count is equal to 6 at this point. In case of pre-increment, it would be, let's rewrite the statement again, 7 plus, 7 plus plus count. So what happens is, in this case, count would be count plus 1, and then it will be added to 7, right? So this is one thing. Now, and now the result would be 13, because 7 plus 6 is 13. And of course, at the end of both statements, count is 6. So this is the difference between post increment and pre increment. I think that is clear, right? uh, Great. Coming back to the loops, it does not matter whether you are using pre increment or post increment, because the value is not getting used anywhere. It is just used for checking, and this check will be done once this statement has been executed. So whether you do post increment or you do pre increment, it does not matter, right? So let's just print the statement percent %d, and let's just print I, right? So this would do gcc loop.c minus o loop dot less loop, and I want to print numbers till 10, and this is the loop, right? So I could have either, you know, if I did not want to use a loop, I would have to do the print again and again. And since I did not know how many, what will be the input by the user, uh, I wrote a loop, and I had to write only one statement. And since the statement is the same, because I will be substituted at runtime, right? And once I reaches 10, it will check whether, after every loop statement, it checks whether the value is there or not. To be honest, it checks before. For example, I is 1, then it will check whether I is less than or equal to number, which is 10 in this case. If it is less, then it will do the loop, then it will update it, then it will check, then do the loop, update, check, update the loop, right? So this is how it works. Now, to do this, when the while loop, uh, while loop is the same thing. While loop also performs the same task, right? It also does the looping thing. So uh, we also need a counter, int I, let's just say counter equals to 0, because 1. So while counter is less than or equals to number, printf uh, %d new line counter trick, and once that has been done, counter plus plus, increment the counter by 1 so that we can check, or else it will get stuck inside an infinite loop. 12, see, this is the first loop, 1 to 12, and this is the while loop, 1 to 12 again. Now The difference between the for loop and the while loop is pretty much nothing. If you talk about the uh, functionality of the loops, the difference is the syntax, right? In the for loop, you have all the three things at one location: initialization, comparison, and update statement. In while loop, you have to explicitly tell, okay, that this is the initialization condition, this is the comparison, and this is the update statement. Now, there's an advantage of for loop, and that is you can, since it is kind of in the syntax, so you do not forget that there is an update statement. Since while loop just has a comparison statement as a syntax requirement, sometimes people forget the update statement and they get stuck in infinite loops. Because if you do not update the counter, let's see what happens if you do not update the counter, right? See, it is just printing one. And why? Because the counter is always one. And since it is always less than 10, it will just keep printing one. Let's say CPU resources, right? My CPU is at 44%. See this. This was the spike. And my memory has also been spiked. So it was this, and then now it is this much. Okay. We have CPU load 42%. See, this is the problem. Now let's just cancel it. We terminated the program, and you see from 40 something percent, 44, 42, it has come down to this much. And this is the 22%, 20% is mostly because of Zoom, because Zoom takes so much CPU. Else it would have been either 1% or 0% because we are not really doing anything, right? So this is the basic fundamental difference between the while loop and the for loop. In case of do while loop, the difference is do while loop is the syntax is this is the condition part, and since the condition is checked at the exit part, right, the condition is checked while we are exiting from the loop. So do while loop executes at least once. Okay, thank you. So I'm using KDE, and these are my gadgets. So I have a CPU load monitor, network monitor. These are my system load bars, memory status, and hard disk usage, right? So coming back to the topic, what we have is this. So the do while loop gives you an advantage where you can execute your loop at least once, which you can do again by tweaking the conditions, the initialization and comparison conditions. And to be honest, there is really no difference. Uh, if we talk about the difference from the compilation perspective, right? At the end of the day, the result is the same. The assembly code generated is the same. If you are disassembling something and there is a loop, you will not be able to tell whether it is a for loop, it is a while loop, it is a do while loop. Well, even I would not be able to tell that. So the thing is, loop is one thing. It's just we have three different syntaxes depending upon the requirements. So I think that is clear, right? Okay, so moving out, moving on to another objective, which is to add all the numbers from one to that number. Let's just use the for loop because that is the easiest or the simplest method. And we will have another number, another uh, thing which will store our result. And let's just set the sum to 0 because initially the sum is 0. And uh, let's say sum equals to sum plus number, right? Because initially the number is 1, so the sum is 0 plus 1. Now when the number is 2, we have to add 1 plus 2, right? So 1 is already inside the sum, and we are adding 2, so it would be 3. So that way, and at the end of the day, I just printf sum is percent %d, and let's just do sum, right? So gcc loop, the number is 10, and I think 1 to 10 is okay. I think there is a problem somewhere in my code. There must be some problem, to be honest. Okay, let's just print it again. So sum, and let's just say number. You print the values of I also. Yes, I'm also printing the values of I. So let's see what is happening here. And okay, so it has for some reason multiplied those values. Oh yeah, so unfortunately I had to use I, and I used the sum. So GCC, and now the sum is 55 as expected. So I was using the value number here, and therefore it was, adding number 10 times because the number was 10. So that is why the sum was coming out to be 100. But I have to add I because I is the number. So 1 plus 0 plus 1, then plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So this is how you add all the numbers from 1 to that number. Now you can do any other thing. To be honest, you can do anything with the loop. You can, yeah, thank you very much. So another thing is you can calculate the sum by using while loop, do while loop, right? It will not make any difference, but it would serve as a little exercise if you are interested in kind of practicing. And that is everything for today, which we decided, and it really took more time than I expected. I did not think it would even take an hour, but it took about 2.5 hours, right? So any questions before we end this session for today, right? Okay, great, thank you. So before closing, what I have to say is, yeah, thank you very much for the feedback. Now, so Animesh has shared a link to the feedback form, which is by the name InfoSec trainer. You can find it in the chat. And I think, let me just copy paste it again to everyone. Just a second. Yeah. So this, okay. Just a second. Let me share you the code. Yeah. So this is the feedback form which you have to fill after the session, so we can evaluate uh, the quality of the session and how did you like it, what you did not like it, and everything like that. So I would say, please go ahead, everyone, and fill the feedback form so that we can improve the quality of our sessions, as well as the code files will be shared with people who will fill the feedback form. So if you want to practice and if you want to ask for the code files, go ahead and fill the feedback form, right? Animesh? Yes, so you have three exercises for today. First one is, you remember when I input -10 in unsigned character as the input, it said the age is 248. So the question is, why did it say the age is 248 when I am inputting -10, right? So the first question is that thing. Second question is to implement the same objective of the loop in the form of while and do while loop. So these are the two exercises for now. And from uh, next sessions, what we are planning is once we have covered the talk, for example, after the talk, we will be sharing proper exercise questions with you guys with the code files for the session, right? So you will have the exercises in written with you. And in case you have any questions, we are going to cover, or we are going to talk about those questions in the next session. Okay, so general loops take more time in execution. So any suggestions from your end, the usage of level of loops? Okay, loops take more time in execution. So suggestion, okay, see, the thing is, if you are using a nested loop, for example, a loop inside a loop, and where you just cannot do this, you cannot solve the problem without a loop inside a loop, then you cannot do anything, right? The basic idea is optimization really depends upon the data set. If there is a direct relation between something and something, which can be solved without using two levels of loops, but with a single level of loop, that's great. In case there is no direct relation between a connection uh, between two data values, so what happens is, well, you have to write nested loops. So it really depends on the data set.
Okay, hi everyone. I guess it's almost 2 and 20 minutes.
Yes.
Okay, so let's wrap it here. And we'll continue from the next time. Okay, guys, we already shared feedback form and it didn't receive any feedbacks. So this time we have a new rule. For the codes, if you want those codes that Himanshu is showing up, if you want those things, you have to fill up that feedback form. Okay, you fill up the feedback form and you will get the code in your email. That's simple. Okay. So if you already filled up the form, you might be getting this code by tomorrow morning, because I guess my email server is down. I have to look into that one. Okay, so I hope you guys enjoyed the session, and we'll see you on Wednesday. The next session is scheduled for that day. Okay, so if you got any questions, anything, ping us, or you can just go and look for, Himanshu, can you pull up that website that we have, Arishti.live?
Just a second.
Just click on your C programming for hackers. Oh, that is not updated yet. So Himanshu have an email address. It's himanshu@aristi.live. You can drop mail directly to that email address and he will be answering on that. If you have any other queries or questions, drop it to hello@aristi.live. I will be taking care of those things. Okay, it will be on footer. And the session is recorded. And Chirag, you're not able to do a copy paste feedback link. Don't worry. If you go to that page, there will be feedback link available as well. So I guess my automation is crashed for some reason. It will be updated by tonight. So you can just fill up the form and you'll get all those things.
Okay, thank you very much.
Okay, guys. So thank you. We'll see you on next time. Bye-bye. And have a nice time.